Welcome to the fourth module of this course. In this section, you will learn why manufacturing plays a critical role in aircraft structures and overall safety. We will walk through the complete aircraft manufacturing flow, from tooling and jigs to metallic and composite production methods, as well as fastening and joining techniques. You'll understand the importance of tolerances, fit-up, shimming, quality control, and inspection, along with common manufacturing defects and challenges. The module also explores how cost and production rate influence manufacturing decisions, the role of digital manufacturing and Industry 4.0, and how manufacturing affects maintenance and certification. In this module, we don't just learn how aircraft are designed. We learn how they're actually built, because the way they're made shapes how safe, efficient, and affordable they ultimately become. And that's what separates great engineering on paper from real-world performance. Design is about what should happen. Manufacturing is about making it happen every time. It takes engineering ideas and translates them into precise parts and assemblies. And in aircraft, this translation is one of the biggest challenges because thousands of pieces must fit and function perfectly in a flying machine. Aircraft manufacturing demands micron-level accuracy because even tiny deviations from design can cause alignment issues, load imbalances, or stress concentrations that compromise structural integrity and safety. Every hole, edge, and surface must be made right the first time to meet tight tolerances and certification requirements. In aerospace, safety is non-negotiable. Parts must be reliably repeatable so each aircraft performs predictably. Quality must be verifiable at every step, and manufacturing systems are built to catch errors early and prevent them from becoming hazards. Quality and safety go hand in hand across thousands of components and assembly joins. How something is made influences how it's designed. If a design is hard to form, machine, or join, manufacturers push back, and engineers refine geometry, material choice, and part interfaces early on. This design for manufacture mindset saves time, reduces risk, and helps the structure be both light and strong. Manufacturing realities like the cost of tooling, ease of assembly, production rate, and need for repeatable processes strongly influence aircraft decisions. While engineers want performance, production planners want deliverability, and the intersection of these constraints defines whether a program stays on budget and on schedule. Manufacturing isn't a back-end task, it's a performance driver. Precision parts and tight assemblies improve weight, fit, aerodynamic smoothness, fatigue life, and fuel efficiency, while manufacturing innovations like automation and lean flow can reduce waste, speed delivery, and enhance reliability across the aircraft lifecycle.